So this is video 7B. It's going to look over touch. The information can be found in your Myers textbook on 141 to 146. So make sure you're labeling your notes as touch. So the receptors for touch is your somatic receptors in the skin. You actually have 4 different types, which we don't need to know for this class, but there are 4 different types that deal with the different stimuli, the tactile stimulation of the different types of stimulation you could be exposed to. So pressure is one, pain is a different stimuli, cold and warmth are 2 other stimuli that could be taken in by your receptors. The known receptor is the one that we do look at in AP Psych, and this is the one because we explore pain. So your sensory receptors take in information, so they take it in, and then they send it to the brain. They send it to the thalamus, and then to the sensory cortex, which is known as the parietal lobe. Some facts that are kind of interesting on touch. Touch from birth is really important. It helps with our attachment bonds with our parents and also helps with trust. Touch can stimulate more weight gain in babies because they feel a sense of comfort. There are different areas in our brain that have different absolute thresholds for us to understand touch as well. One thing that impacts our touch is the bottom up, top down theory. Top down and bottom up processing can change our response to how we respond to touch. Top down remembers your prior knowledge. When you're aware that someone will tickle you, you might change your response to how you intake that touch. Another one is the rubber hand theory. When a researcher stimulated and touches a rubber hand while yours is covered, you start to actually feel and process that sense of touch. Okay, so you're having this prior knowledge that this is happening to you, which causes you to actually experience as if that is happening to your own hand. Bottom-up processing is being unaware, of what the touch could feel like or that it's going to happen, which can change your response to you being touched and how you process it. Understanding pain is one of the areas we're going to look at. Okay, pain is helpful because it's a warning sign to our body in distress. Now, we're not going to look so much at cold and the other, I would say, the pressure. The one that we really focus on is pain. Understanding pain will change from person to person. This is really due to what they believe is the biopsychosocial approach. So pause this, copy this chart down in terms of how the different biological, psychological, and social influences influence our understanding on pain. First one we're going to look at is the biological approach. Biological approach is how your body and your brain impacts your understanding on pain. Pain receptors are often known as known receptors. They are the receptors that take in pain, which are the sensory receptors that detect harmful temperatures, pressure, and chemicals. Touch is not registered in one area of the body. It's registered all over, which causes it to be processed all over the brain. Biologically also, there's different genetic differences and differences in endorphins productions that can impact your ability to manage pain. Okay, genetic mutations, different levels of endorphins your body creates. Biologically, also there's this phenomenon called the phantom limb phenomenon. People who lose a limb can still feel sensation in their missing limb. This happens because the sensory neurons are still in their body, which once would send signals to different areas of the body, which are causing the brain to misinterpret the information. The last theory that deals biologically is the gate control theory. The gate control theory is an explanation for pain control that proposes we actually have a gate in our spinal cord that under some circumstances helps block pain from going up to the brain. It tries to explain how our body actually deals and manages with pain. Rubbing certain areas in the body where you're processing pain can sometimes help close the gate, they believe. Endorphins in this area also can help manage pain in your body. And pain medications sometimes can work to block the sensory neurons from actually going up your spinal cord to reach the brain. So this is different biological ways your body is managing pain. Ronald Meslak and Patrick Wall really researched this theory. Psychologically, how we process pain is how one thinks about pain. When when you're experiencing pain, sometimes distraction can occur where your focus is elsewhere, so you're not thinking about the pain. These are known as the cognitive distractions. So as an athlete, you might be so focusing on winning a game that you don't realize that maybe you rolled an ankle in the last play and your ankle is throbbing with pain. Memories of pain are usually remembered, and they could also impact how you think about pain. Social is a big impact on understanding pain. How our environment impacts how one understands pain. The presence of others. Maybe you're in a large crowd, so you don't want to experience the pain or feel the pain. Empathy from others can cause you to feel the pain. People understand you, so now you're more willing to accept the pain. And cultural expectations. Okay, no pain, no gain. Suck it up, buttercup. People are not expected to experience pain and cry in public. Controlling pain, there's different ways you can control pain, bio, psycho, and socially. Drugs are different ways to manage pain. Surgery, acupuncture is used, electric stimulation, massage, exercise, relaxation, and therapy are different ways to manage it. You have two different additional senses that connect to touch. You have vestibular sense and you have the kinesthetic sense. These kind of streamline off of touch. Touch is connected to the vestibular sense. Okay, the vestibular sense is the sense of your body movement and your position. And this includes your sense of balance. So understanding and being able to balance. Your inner ear actually has your vestibular sacs and your semicircular canals that help you deal with balance. That they connect to the cochlea and they're filled with fluid. So up here in the drawing, you have your semicircular canals and your vestibular sacs. Both help you feel balanced. So if you were to spin around over and over and over 10 times in the class, how you gain your balance and your ability to stay balanced is because of your vestibular sense. Okay. If you didn't have your vestibular sense, it would feel like you're on a boat rocking all the time. Okay. The dizzy after effect, if you're constantly dizzy, okay, it's what's known as vertigo, and that might be a damage to your vestibular sense. You also have your kinesthetic sense. Touch connects to the kinesthetic sense. The kinesthetic is the system of sensing your body position and moving of body parts. You are aware of your body parts at all times. If you were to close your eyes, okay, and be able to touch the your legs and your arms, you're aware of where your body parts are in position to you're aware of your body parts in position to your body. You are aware of that if you lean too much to the right, you're not in central position. Your proprioceptors are specialized nerve cells in your muscles and tendons and joints that tell you about your body movements. And we'll go more into this in class.